Okay, so it occurred to me that I always start these out with okay, so, but I guess that's my thing. Anywho, today we are going to be taking notes on different types of molarity aspects. So I'm going to say molarity continued. Now, just to refresh your memory, remember that molarity is capital M and it is moles over liters. So what you're going to take notes on now is just kind of different variations on what we can do with molarity. Now, the first thing we're going to be able to do is, or the first question it's going to ask is find the volume. And let's do example 1. 3.5 moles of NaCl to prepare 0.75 molar solution. Let me zoom in. So how I attack these problems is like so. So I see that the molarity is 0.75 molar. And that just means 0.75 moles over liters, right? Because we know that molarity, capital M, is moles on top and liters on bottom. So, next thing I'm going to do is write it like this. 0.75 equals moles over liters. Because 0.075 or 0.75 is moles on top and liters on bottom. So now that I know this question almost becomes just a proportion. They've told me that I have 3.5 moles of sodium chloride, and they've given me this molarity solution. And they want me to find the volume. And that really means find liters. So this just becomes a simple proportion. I have 0.75. I know that I have 3.5 moles. So I plug that into the mole part, 3.5 moles, all over liters. And that's what I want to find. I want to find the volume, which is liters. So I'm just going to cross multiply. So 0.75 times liters equals 3.5. Because technically this guy's over 1. And you multiply those two together. And that's where I get, let me go ahead and color code this guy for you guys. That's where I get 3.5. 1 times 3.5 is 3.5. So you solve for liters, divide each side by 0.75, and your calculator spits out 4.66666, keeps going on and on. Look back at what they gave you, 2 sig figs, 2 sig figs, so your final answer should have 2 sig figs. 6 bumps it up, so the final answer is 4.7 liters. They wanted volume, and you were actually solving for volume, which is liters. So the unit was right there. So let's do another one of these examples. I'm going to do it right next to it in the second column. Example 2, 1.76 moles of KCl to prepare a 2.50 molar solution. So with these problems, you always start with the molarity. So we know that the molarity is 0.250 molar, big M. Now this big M actually means moles on top and liters on bottom. So I'm going to say moles over liters. Actually, sorry, wait. That's 2.50 moles over liters. Moles on top, liters on bottom. So that equals, that's the same thing as saying 2.50 equals moles over liters. And now that we've got this little equation we've made for ourselves, we know that moles is 1.76, so we can go ahead and plug in 1.76 into this moles. It's just a simple proportion. So 2.50 equals 1.76. We know moles go on top, all over liters. And it wanted us to find the volume with these circumstances. So I'm finding the volume. Technically, this guy is over 1, so I cross multiply. That gives me 1.76 equals, cross multiply the other two, 2.50 times liters. You want to solve for liters, so you divide each side by 2.50. And your calculator is going to spit out, actually it spits out 0.704, I believe. Just type that into our calculator really quickly. 1.76 divided by 2.5, yep, 0.704. And that's actually the right number of sig figs. 3 sig figs here, 3 sig figs here, so the answer is 3 sig figs, so 0.74 liters. Now there is a second type of problem, and I'm going to do just one of those. So the second type of problem is going to be calculate the number of moles. And with this guy, it's the same exact idea. So I'm going to write example 1 out. 3.50 liters of a 6.0 molar solution. So they're saying, hey, you've got this volume and it has this concentration. How many moles is it? So you always start with your molarity. So we know that it's 6.0 molar, and that just is same thing as saying 6.0 moles over liters. So I can say that 6.0 equals moles over liters. So I'm just kind of making myself a proportion step by step. Molar means moles over liters, so 6.0 equals moles over liters. And notice they give us liters here. So I can plug in this 3.50 into the L section. So I'm going to go ahead and do that. I'm just going to do it over here to give myself room. 6.0 equals moles all over the liters, 3.50. So see, I just plugged in the 3.50 in the liter part. And they wanted moles, and notice I've got moles blank. So technically the 6.0 is over 1. So I'm going to cross multiply. So that gives me moles equals 6.0 times 3.0, which gives me 21. So 21 moles. And that is the right number of sig figs. 2 sig figs, 3 sig figs, lower number is 2. So that's your final answer. Okay, so these are just very simple. You're just using the concept that molarity is moles on top and liters on bottom. And once you've got that, you can just plug in information. You have your number from molarity. You know it's moles over liters. They give you liters, so you plug it in, and you solve for moles. So it's just a simple proportion. I know I'm saying it's simple, but I know it doesn't seem that way to you guys. But you will get the hang of it tomorrow, either tomorrow or on Wednesday. So the last type of problem is a little bit more difficult. There's an extra step involved at the end, and it's going to be calculate the mass necessary to make the following solutions. So the first example that I'm going to give you guys is 4.6 liters of a 2.50 molar NaCl solution. That's my abbreviation for solution. So that way we just don't have to write out the words all the time. Okay. They want us to calculate the mass. We can't find mass from molarity. But we can find moles. Oops. So we can find moles, and then we can just go from moles to grams. Because when they ask for mass, they want grams. So just like I did in the last problem, I'm going to take my molarity. Always start with your molarity. They give you 2.50 molar. Now that just means 2.50 moles over liters. And that basically just means 2.50 equals moles over liters. So do you see that progression there? So I'm going to start with this information. 2.50 equals moles over liters. Now they want me to find the mass. I can't find the mass right away. What I can do is I can find the moles. Notice they give me a volume. They give me 4.6 liters. I can plug that into the liters section right there. So I'm going to go ahead and do that. So 2.50 equals moles over 4.6. So I'm going to calculate this out. I'm going to cross multiply. So moles times 1 is just moles. And then 2.50 times 4.6 is 11.5. Now it's 11.5 moles of sodium chloride that we just solved for. So once again, 2.50 is same thing as moles over liters. That's my molarity. They wanted mass. Can't find mass. I can find moles though. I plugged in 4.6 in the liters section, and I solved for moles. Now it's moles of sodium chloride. They didn't want moles of sodium chloride. They wanted grams. So we just do a quick little island hop here. For every 1 mole of NaCl, there's 58.443 grams of NaCl. Type that into your trusty calculator, and it spits out 672.0945. There's 2 sig figs. 2 sig figs here, 3 sig figs here, so 2 sig figs based on the 4.6. So 2 sig figs, so your final answer is 670 moles. Oh, I'm sorry, not moles, grams. Moles canceled out. Grams of NaCl. If you guys remind me tomorrow, I'll give you guys a point for that. So just make a little note on your notes and say, remind Mrs. Garvin to give you a point. Let's try one more of those examples, and then you'll be all through with tonight's notes homework. So example 2, let's say if I have 0.55 liters of a 6.0 potassium chloride KCl solution. So you always start with your molarity. Oh, a 6.0 molar, molar KCl solution. And so 6.0 molar KCl solution. So I start with what they give me, my molarity, 6.0 big M, right? And molarity, big M, that just means 6.0 moles over liters. And I could rewrite that as 6.0 equals moles over liters. So they wanted me to calculate the mass necessary, which is grams. I'm going to have to find moles first, so I'm going to go ahead and do that. So I see they give me liters, so I can plug that liters in right down here. So 6.0 equals moles, and they give me liters, which is 0.55. Technically, the 6 is over a 1, and I'm just going to cross multiply these guys. So moles equals, cross multiply these two, 6.0 times 0.55. That gives me 3.3 moles, and it's of KCl, because they said it was KCl right here. So once again, they asked for the mass, so I'm going to convert my answer from moles to grams. So they give me moles, going to go to grams. So for every 1 mole of potassium chloride, there's 74.551 grams of KCl. Moles go, type that into your calculator, it spits out 246.018. Sig figs, 2 sig figs, 2 sig figs, answer has 2 sig figs. So your final answer is 250 grams of potassium chloride of KCl. Okay, so your only homework tonight is to make sure you finish 15.1, and we're just going to go ahead and work on 15.2 tomorrow in class. I hope you guys have a wonderful evening, and remember to ask for that point.